Welcome to the deep dive. Today, we're cutting through the noise to deliver your shortcut to building truly game-changing systems. We're talking about the rapidly evolving world of LLM-powered agents.
Big topic right now.
Absolutely. And if you're wondering what an agent really is, well, think of them as systems that can independently accomplish tasks on your behalf. It's a pretty significant leap beyond, traditional automation.
Definitely a leap.
So our mission in this deep dive is to pull back the curtain on a comprehensive guide. We want to share the must-knows for any product or engineering team ready to transform workflows, thinking about everything from the initial concept right through to a robust deployment. Okay, so let's unpack this. What exactly is an agent, and how do they differ from the software we're all used to? Conventional software, it typically streamlines workflows, right? Helps you do things faster.
Yeah, efficiency tools, basically.
Exactly. But agents, they take it a step further. They can actually perform those workflows for you, and they do it with a truly impressive degree of independence.
That independence is the key word, I think.
It really is. And just to be clear, we're not just talking about a simple chatbot that gives you one answer or like a sentiment classifier.
No, those are different beasts.
Right. Those don't use LLMs to control the actual execution of a workflow across multiple steps. That's the distinction. A true agent, it has some core characteristics. First, it leverages an LLM, the large language model, to manage the entire workflow execution and make decisions.
Okay.
So it knows when a task is complete, it can proactively correct its own actions if something goes a bit sideways.
Self-correction. Interesting.
Yeah. And it even knows when to just stop execution and hand control back to you, the user, if it hits a wall it can't figure out.
So it knows its limits.
Hopefully, that's the goal. Second, it has access to various tools, thing functions, APIs, ways to interact with external systems. It needs these both to gather context, get information, and to actually take actions.
Right. The hands of the agent, so to speak.
Exactly. And crucially, it dynamically selects the right tools for the situation. It's not just following a fixed script, all while operating within, clearly defined guardrails. We'll get to those. This even includes interacting with older legacy systems by basically mimicking how a human would use them, navigating UIs, clicking buttons, filling forms, that sort of thing.
That independence you mentioned sounds incredibly powerful, but it also raises a question for me. How do you prevent that independence from, going rogue? Are there hidden risks with giving an LLM quite so much autonomy, especially when it's interacting with external systems, making decisions on its own?
That's a crucial point, absolutely. And it's something we'll definitely dig into when we talk about guardrails later. Big topic.
Good deal.
But for now, let's look at the strategic question. When is an agent not just nice to have, but absolutely essential? And conversely, when are traditional approaches still probably your best bet?
Now, where's that line?
Because the true unlock with agents isn't just optimizing the tasks you already do, it's automating workflows that were, frankly, previously impossible to tackle with traditional software.
Right, things that were just too complex or ambiguous.
Exactly. Think about payment fraud analysis, for instance. A traditional rules engine, it's like a rigid checklist. If X happens, then flag it. Very deterministic.
Black and white.
Totally. But an LLM agent, it functions more like a seasoned investigator.
Okay, I like that analogy.
Yeah. It evaluates context, considers subtle patterns, and it can spot suspicious activity even when there are no clear-cut rule violations.
So it's seeing the gray areas.
Precisely. That nuanced reasoning capability is why agents excel in these complex, ambiguous situations. It's like upgrading from that rigid flowchart to a detective who can, smell a rat even before it's broken a single rule.
The kind of investigator who just knows something's off, maybe.
Exactly. That intuition, but kind of translated into code. That's what we're talking about. So if your team is, say, hitting a wall with complex decisions or wrestling with really unmanageable rule sets that are brittle and hard to update.
Yeah, those rules engines can get crazy complex.
Oh, tell me about it. Or if you're drowning in unstructured data, like text, documents, emails, that's your cue. That's where agents don't just streamline, they really transform things.
Can you give some specific examples of those categories?
Sure. For complex decision-making, think about approving refunds in customer service. Lots of nuance, exceptions, context needed.
Right, not always straightforward.
Not at all. For difficult to maintain rules, maybe performing vendor security reviews, those rule sets can become massive, super intricate, costly to update, easy to break.
Yeah, a maintenance nightmare.
Definitely. And for heavy reliance on unstructured data, think about processing a home insurance claim. You've got descriptions of damage, photos, maybe conversations.
Lots of free-form text and interpretation needed.
Exactly. Interpreting natural language, extracting meaning, interacting conversationally, that's prime territory for an agent.
So, if these are the prime use cases, what's been the biggest hurdle for product and engineering teams trying to tackle them with traditional methods before LLMs came along? Is it purely the complexity, or are there sort of underlying technical limitations? Because like you said, these areas have just resisted automation for so long.
Yeah, historically, it's really been that blend of complexity and just the sheer amount of variability. Traditional systems, they really struggle when the rules aren't neat and tidy, or when they rely on interpreting the messy reality of human language and unstructured information.
Right. Computers like structure.
Yeah.
Humans, not so much.
Pretty much. And that's where the LLM's ability to understand context, ambiguity, and generate dynamic responses becomes, indispensable. Okay, so we know what an agent is roughly and when you might absolutely need one, but how do you actually get your hands dirty and start building one? Let's break down the fundamental DNA of an agent, the core components.
All right, the building blocks.
Yeah. At its core, an agent really consists of three essential parts. First, you have the model. That's the LLM itself, the brain powering the agent's reasoning and decision-making.
Got it, the core intelligence.
Right, and different models have different strengths, right? Task complexity, latency, cost.
Trade-offs everywhere.
Always. Not every task demands the absolute smartest, most expensive model. A smart approach, the guide suggests, is to maybe prototype with a really capable model first, establish a baseline for quality.
See what good looks like.
Exactly. Yeah. Then you can try swapping in smaller, maybe faster or cheaper models where the results are still acceptable. Optimize from there.
Makes sense. Iterate down.
Second, we have the tools. These are the external functions or APIs the agent can actually use to take action.
So the hands again.
The hands and maybe the senses too, yeah. Tools extend an agent's capabilities, allowing it to interact with your underlying applications or systems. Databases, CRMs, email, websites.
Even those legacy systems you mentioned.
Yep. It's crucial that these tools are standardized, well-documented, and reusable if possible. Makes life much easier.
Standardization is key for scaling, I bet.
Absolutely. We can broadly categorize them into three types. First, data tools. These are for retrieving context and information. Think querying databases, reading PDFs, searching the web.
Gathering intel.
Right. Second, action tools. These are for interacting with systems to take actions. Sending emails, updating CRM records, handing off customer service tickets.
Making changes in the world.
Yep. And third, an interesting one, orchestration tools. This is where agents themselves can actually serve as tools for other agents.
Oh, okay. Agents calling agents.
Exactly. Like you might have a specialized refund agent or a research agent or a writing agent that another agent can call upon.
Cool. Building blocks made of building blocks.
Kind of, yeah. And finally, the third core component is instructions. These are the explicit guidelines and guardrails that define how the agent behaves. Your rulebook.
The prompt, essentially. Or more than that.
It's often based on the prompt, but it's really about high-quality structured guidance. It's critical for reducing ambiguity and improving the agent's decision-making. Fuzzy instructions lead to fuzzy results.
Garbage in, garbage out still applies.
Always. Some best practices here include using existing documents like standard operating procedures or support scripts to create LLM-friendly routines. Prompting agents to break down complex tasks into smaller, clearer steps, defining very clear actions for every single step.
Making it explicit.
Very explicit. And importantly, capturing edge cases. You need to anticipate common variations or problems and include specific instructions on how to handle them, maybe with conditional steps.
Thinking through the what-ifs.
You have to.
The real power I see there is how these three components, the brain, model, the hands, tools, and the rulebook instructions are so inherently interdependent. Like, you could have the smartest model in the world, but without well-defined tools and precise instructions, its operational capability is, severely limited, isn't it?
Absolutely limited. You need all three working together.
Each one seems indispensable for building reliable agents that can actually perform these complex tasks autonomously.
Well said. So with those foundational pieces in place, your model, tools, instructions. The next challenge is, how do you get them to sing together? How do they coordinate? That's the art and science of orchestration.
Okay, making it all work.
Right. And the guide strongly recommends an incremental approach here. Don't try to build the, fully autonomous, super complex agent right out of the gate.
Start small, iterate. Sounds familiar.
It's good advice. Generally, orchestration patterns fall into two main categories. First up, single agent systems. Here, a single model, equipped with its tools and instructions, executes workflows in a loop. It just keeps going until an exit condition is met, like it produces the final output, or maybe it hits an error it can't resolve.
So one brain driving everything.
Pretty much. And a single agent can actually handle quite a lot of tasks, especially if you incrementally add more tools to its toolkit. Complexity can often be managed quite effectively using flexible prompt templates. The guide mentions something called policy variables.
Policy variables, what are those?
Think of them as dynamic settings within your main prompt or instructions. They allow the agent to adapt its behavior based on the situation, maybe who the user is, or what the specific task variant is, without needing a complete rewrite of its core logic.
Like configuration settings for the prompt.
Sort of, yeah. Gives
Yeah.
you flexibility. Then we have multi-agent systems. This is where workflow execution is distributed across multiple coordinated agents.
Okay. When does that become necessary?
Good question. The guide suggests you might consider splitting tasks across multiple agents when maybe your prompts become really complex with lots of conditional logic, lots of if this, then that.
It's hard to manage in one prompt.
Exactly. Or when you encounter what they call tool overload.
Tool overload.
Yeah, meaning maybe your tools are too similar or they overlap too much, causing the agent confusion about which one to use. And just improving the tool descriptions doesn't seem to fix the performance issues.
So the agent gets confused about its hands.
Right. At that point, splitting responsibilities across specialized agents might be clearer. Within these multi-agent systems, there are two sort of broadly applicable categories or patterns. First is the manager pattern. Here, you have a central manager agent that coordinates multiple specialized agents. It does this usually via tool calls. Remember, agents can be tools.
Right. Agent calling agent.
So the manager delegates tasks to the specialists. It gathers and synthesizes their results, and it maintains a unified user experience. The user only talks to the manager.
Like a team lead.
Exactly like a team lead. This is ideal when you want one agent controlling the overall workflow and interacting with the user. An example they give is, say, a translation manager agent. It gets a request, figures out the languages, and then delegates the actual translation to specialized Spanish, French, or Italian agents. Then it combines the results.
Okay, that makes sense. Central control.
Yep. The second pattern is the decentralized pattern. Here, multiple agents operate more like peers. They hand off workflow execution to one another.
Handoff, like passing a baton.
Kind of. It's usually a one-way transfer. It's often implemented as just another tool, a handoff tool. The new agent takes over the execution and the conversational state from that point.
So no central manager overseeing things.
Not necessarily. This pattern is optimal when you don't need a single agent maintaining central control or synthesizing results from multiple streams. A great example is customer service. A triage agent might handle the initial query, figure out what's needed, and then hand off the entire conversation to a specialized technical support agent or a sales agent or maybe an order management agent.
Okay, so the specialist just takes over completely.
Exactly. The triage agent is done at that point.
You know, it makes me wonder about the strategic choice behind these orchestration patterns. It's clearly not about which one is inherently better, but it seems like a trade-off, right? What's the optimal balance between that centralized control of the manager pattern versus the distributed expertise in the decentralized one for a specific workflow? How do teams figure out that tipping point where a single agent just isn't cutting it anymore?
Yeah, that's the million-dollar question, isn't it? And the guide really emphasizes that it's often an evolutionary process. You probably start with a single agent because it's simpler.
Keep it simple, stupid.
Right. And as you add more tools, more logic, and you start hitting those complexity ceilings or that tool overload problem we talked about,
That's the trigger.
that's often the trigger to start thinking, okay, maybe we need to specialize. Maybe a manager pattern fits, or maybe a decentralized handoff makes more sense here. It depends on the workflow. Okay. Now, with all this power, this autonomy we've been discussing, comes responsibility, huge
Yeah.
responsibility.
The safety aspect.
Exactly. How do we ensure these agents operate safely, predictably, and importantly, in line with our values or our company's brand? That's where guardrails come in. absolutely critical.
Okay. What kind of guardrails are we talking about?
Well, fundamentally, guardrails help you manage critical risks. Things like data privacy, you don't want agents leaking sensitive info or system prompts.
Definitely not.
And also reputational risks, ensuring the agent's behavior, its tone, its actions align with your brand. You don't want it saying or doing something inappropriate.
Brand safety is huge.
It is. The recommendation is that guardrails should be layered. You don't rely on just one thing. You combine them with robust authentication, authorization, access controls, the standard security stuff.
Defense in depth.
Precisely. Because let's be honest, nobody wants an agent that accidentally cancels their customer's flight or, I don't know, orders 100 pizzas for their neighbor.
Chuckles. Probably not ideal, no.
So these guardrails are critical for keeping the agent on the straight and narrow. The guide details various types. For instance, a relevance classifier. This basically ensures responses stay within the expected scope. It flags off-topic queries.
Like asking a customer service bot about the weather.
Exactly. If it's supposed to handle billing questions, and someone asks, how tall is the Empire State Building?
Right.
The relevance classifier should catch that. Then there's a safety classifier. This detects unsafe inputs, like attempts at jailbreaking or prompt injection people trying to trick the agent into revealing its system instructions or doing harmful things.
Protecting the agent itself.
Yes. A PII filter is crucial for preventing unnecessary exposure of personally identifiable information. You want to scrub that where possible.
Data privacy 101.
Yep. Moderation guardrails flag harmful or inappropriate inputs, hate speech, harassment, that kind of thing.
Standard content moderation.
Right. Tool safeguards are interesting. This involves assessing the inherent risk of each tool the agent can use.
How risky is sending an email versus just reading a database?
Exactly. You might categorize them low, medium, high risk based on factors like read versus write access, whether the action is reversible, financial impact.
And trigger different actions based on risk.
Correct. A high-risk tool use might require human approval, while a low-risk one runs automatically. Then you have simpler rules-based protections. These are just straightforward deterministic measures, block lists for certain words, input length limits, maybe rejects patterns for known bad inputs.
The simpler stuff still has its place.
It does. And finally, output validation. This checks the agent's response before it goes to the user, ensuring it aligns with brand voice, values, doesn't contain disallowed content, etc.
Checking the final product.
Right. So the general heuristic the guide suggests for building these guardrails is start by focusing on data privacy and content safety first. Those are table stakes.
Get the basics right.
Then add new guardrails incrementally based on real-world edge cases and failures you actually encounter during testing or early deployment.
Learn from mistakes.
You have to. And finally, continuously optimize for both security and user experience as your agent evolves. You don't want guardrails so tight they make the agent useless.
Finding that balance.
Exactly. And crucially, perhaps the most important guardrail, especially early on, is human intervention. Human in the loop.
The ultimate safety net.
It really is. It allows the agent to gracefully transfer control to a human when it gets stuck or when the stakes are too high. There are two primary triggers that typically warrant kicking things over to a human. First, exceeding failure thresholds. Like if an agent fails to understand the user's intent after maybe 2 or 3 attempts.
Don't let it spin its wheels forever.
Right, just escalate. Second, high-risk actions. Anything sensitive, irreversible, or with high stakes, think canceling user orders, authorizing large refunds, making payments.
Things you really don't want going wrong.
Yeah, absolutely. Those should probably trigger human oversight, at least until you have extremely high confidence in the agent's reliability for that specific action.
You know, a crucial point that often gets overlooked, I think, is that inherent tension between control and capability you mentioned. How do we design these safety nets so they're genuinely effective, but without completely stifling the agent's core purpose, its ability to act autonomously?
That's the balancing act.
Yeah, it feels like it's about building a sort of trusting, collaborative relationship with the agent, where human oversight steps in precisely when it matters most, ensuring both safety and efficiency, and maybe even helping the agent learn to be better and safer over time through that feedback loop.
That's a great way to put it. It's not just about stopping bad things, it's about guiding the agent effectively. So just to recap our journey here, agents, LLM-powered agents, they truly mark a new era in workflow automation. They allow systems to reason through ambiguity, take action across various tools, and handle complex multi-step tasks with a really high degree of autonomy.
And critically, as we discussed, agents are uniquely suited for those use cases that have historically been tough nuts to crack things, involving complex decisions, understanding unstructured data, or replacing brittle, hard-to-maintain rule-based systems. That's the real game changer here, I think.
I agree. And to build reliable agents, the key takeaways from the guide are pretty clear. You need strong foundations. That means capable models, well-defined and documented tools, and clear, structured instructions.
The brain, hands, and rulebook.
Exactly. Then, thoughtful orchestration is essential, probably starting with a single agent, keeping it simple, and only evolving to multi-agent systems when complexity genuinely demands it.
Don't over-engineer it from day one.
Please don't. And perhaps most importantly, critical guardrails need to be in place at every single stage, from filtering inputs to safeguarding tool use to robust, human-in-the-loop intervention.
Safety first, last, and always.
Absolutely. It's all about ensuring these powerful agents operate safely and predictably. So, for you listening, whether you're a product lead sketching out next-gen features or maybe an engineer deep in the code, this isn't just an abstract concept anymore. The path to successful agent deployment, as the guide makes clear, is highly iterative. You start small, you validate with real users, get that feedback, and you grow capabilities over time.
Learn and adapt.
Precisely. This isn't just about building software in the traditional sense. It feels like it's about building a new kind of intelligent partner almost. And as you consider the possibilities for your own work, here's maybe a final provocative thought to leave you with. Agents automate not just tasks, but entire workflows with intelligence and adaptability. What truly new possibilities emerge when systems can genuinely act on your behalf, navigating complexity you once thought was completely impossible to automate.
It opens up a lot of doors.
It really does. We encourage you to keep exploring how these intelligent systems are reshaping our world. It's happening fast.